Yeah, good evening. So my presentation is titled The Sky in 13,372, Other Things to Mostly Look Forward to. In a sense, this is actually a retrospective because it's bits and pieces of presentations that I have given before, one of which was in a blizzard when we were doing our Recreational Astronomy Nights at York University. So I'm thinking some people may not have seen this before, or they may have forgotten it, and like the next day you go, oh, this is interesting, at least so I hope. Okay, so I'm going to cover basically three different kind of subtopics in this kind of portmanteau. Like I say, it's like a few different presentations. We won't call it a Frankenstein presentation. So we're going to talk about the moon's orbit in 2024, 2025. We'll take a look at some planetary gatherings of interest, and then we'll look at the weird and wonderful far future. So RASC members, as you know, you always get the Observer's Handbook, and the Observer's Handbook is actually got, even the parts that you might think are boring are probably worth looking at, because sometimes you learn something and go, hey, I didn't know that. I'm still trying to digest the whole binocular and eye relief and pupil diameter stuff. It is extremely detailed, but we're going to talk about something a little bit different that I do understand. So in the moon section, which people might skip because, you know, the only thing is the moon is like up there and get out of the sky, please. This is actually a quote from part of the handbook, and there's a lot more interesting information, but we're just going to excerpt it. The moon's orbit is tilted some 5 degrees to the ecliptic, with the nodes crossing points of its orbit regressing rapidly, and regressing means it's moving along. In 2024, the effect is additive, with the moon having a declination range from plus to minus 28.1 in January, increasing to a range of plus to minus 28.7 in September and October, flattening out as we approach the major lunar standstill of 2025. And yes, major lunar standstill is capitalized. There's a Wikipedia article on it. That just means the moon is like basically at its extreme high and low point, or a more extreme orbit. So this is from page 159, and there's a bunch more interesting information, like our moon is quite unusual in the solar system for not being on our equator, being on the ecliptic, so kind of traveling with the other planets, which means it's higher at some time of the year and it's lower at other times of the year, at least when you notice it. So people know that in winter the full moon is like way up in the sky, but the full moon in June, well, it hits your eye like a pizza pie maybe, but it's quite a bit lower. So that's the effect of the moon not following our equator, and this effect actually can subtract or add to that. So what's it mean? For the next couple of years, and that's 2024 and 2025 basically, the moon will be both as high and low in the sky when at the meridian, which is when it kind of stops rising and starts setting, as it can possibly be. The Observer's Handbook does, on the same page, have a handy table of the moon's passages through the high point at about 6 hours right ascension, which is in the constellation of Taurus. And vice versa south of the equator. So if you're looking at the moon from Chile, the Observer's Handbook table of the highest passages for you would be the lowest passages. However, what I think is more interesting than just, oh, well, this is the high point, is if we can actually go out and take a look up in the sky and go, holy moly, that moon is way up there. So rather than just the plain day, because if you go out at the wrong time of day, it might be rising, it might be setting, it might be low on the horizon. I actually went and played with Stellarium for a while to actually get the times when it's actually the highest in the sky. So if you go out at that precise time, that's about as high as it will get. You can go, this is pretty impressive, hopefully. The following table, which I did myself based kind of on that table in the Observer's Handbook, it's the highest moon viewing opportunities for Toronto, so the times will vary elsewhere. If you're in Calgary or St. John's, it'll be a different time. You'd have to figure it out for yourself, maybe using Stellarium. The lowest moon, which is the highest moon in the southern hemisphere, will happen like 2 weeks on either side. So just as the moon goes around in basically 4 weeks. 2 weeks after it's as high as it can be, it's going to be as low as it can be, but I haven't really called that one out. So here's the table. People want to take a picture of that, or I'll probably post it to our forums. And later on, I'll probably come back at the end of my presentation and put it up if you want to write it down. So for instance, this month on January the 22nd, if you go out at 10:20 p.m., give or take a few minutes, you'll see the moon as high as it can possibly be. That's when it'll be like pretty much due south. These phases that I have listed there, those are actually taken from the Observer's Handbook. So a high phase waxing gibbous, that sounds pretty impressive, doesn't it? It means it's gibbous, which means it's past quarter moon, but it isn't full moon yet, but I'm not quite sure what high phase means. So what happens is that each month, the high point has actually got a slightly different phase, as you can see there, because every month the moon passes through that time about an hour earlier or so, a couple of hours earlier. So February the 18th, moderate waxing gibbous. And you can see it gets earlier. So January, February, and March are the times we can see it in the sky. March would be kind of in early evening. In April, it's pretty much in daylight. And then I skipped all the ones where it's high in the sky during the daytime because I don't think that's quite as interesting, but you can go look that up as well if you want. It will also be quite a bit thinner when it's in the sky during the daylight because it's close to the sun, so it'll be harder to see. In my opinion, it wouldn't be quite as spectacular. Then once we come into the autumn season this year, September the 24th, last quarter, if you're up at just before 7 a.m., and it comes through and it becomes closer and closer to full and earlier in the night, or not as early, I guess I would say. So for December the 16th, it's pretty much the full moon, and that's probably spectacular if it's clear. If there's snow out, it would be like lighting everything up because it will be extremely high in the sky. It'll be almost 75 degrees up, which means it's only 15 degrees from the zenith, which is, as I say, unusual because once the moon's orbit moves on, it's not going to make it that high. And that's why I added in the December the 15th and the 17th on either side, because it'll still be pretty high and it'll be quite close to the full moon. So hopefully people will get a chance and go out. Like I say, you want to do it on that specific time. Hopefully it's clear. Okay, so next we'll take a stellarium tour. Jumping off from today's date, we're going to go to 1942, and I'll explain why when we get there. We'll go to 2025, and that is next year. I had to change that from 2024 being next year, and I went, wait a minute. So welcome to almost a quarter of the way through the 21st century. And then we're going to go to the year 13372. Again, I give a shout out to Stellarium. It's a free application. It's open source software that is provided for free. So you go to stellarium.org, you download it, and you can do a lot of really interesting poking around in the sky using Stellarium. Okay, so here we are in Stellarium. I don't usually use a mouse, so bear with me. So right now, the time is pretty much today. As you can see down here, we're here and now right now, so I'm going to just freeze time because it slows it down a little bit and makes the CPU run a little bit better. And this is pretty much what Andy told us. He didn't lie to us. There's like Jupiter up there and Orion is coming up. It's a little after the 6:30 that he had for his big picture. So we're going to call up the, to double click that, maybe. Oops. Oh, that's interesting. Oh, there we go. Excellent. Well, yeah. And it is fairly hard on CPUs, but I'm running a laptop that was a refurbished laptop purchased 10 years ago, and it still runs, and the latest version does run, so it just takes a long time to load. Sorry, I'm having some issues seeing the keys here. Very good. So now we're in the year 1942, which honestly, in the terms of history, was not a very good year for a really lot of people. World War II was well in swing. Lots of bad things happened there. But if you were in Toronto and it was clear, take a look overhead. You've got Jupiter and Saturn and Mars in a beautiful lineup. Now, if we go over to the west, we don't quite see too much there, but let's just run time back. And there's Venus as well. So on this date in 1942, if you went out there at, I don't know, that's like 6:11 p.m., you would see 4 of the planets spread across the sky, and the 4 bright planets. And here's the other kind of neat thing, is if we run the date forward, Venus gets closer to the sun, but, whoops, there we go. Mercury also shows up there. So later in that month of January 1942, all 5 planets would be visible if you had a clear sky. All 5 of the classical, well-known planets would have been visible in the sky. So that's kind of neat. I'm not entirely sorry. I don't think that I missed that because, like I say, 1942 was a pretty crappy year for everybody. But these planetary gatherings do come up. And the reason I know about it, by the way, I'll put in a plug for the library at the Carr Astronomical Observatory, the Treijs Library. They have the observers' handbooks and the journals from way back in the past, and I just came across that randomly just browsing stuff. So, like, you never know what you're going to find until you go look. So let's go back to today. So we're back at today at 2014, and we're going to go forward just 1 year. Whoops, go forward. There we go. So this time next year, we actually have an interesting proposition as well. There's Venus. Saturn isn't that bright. Oops, there we go. Saturn is kind of dimmish at magnitude 1 point something, but Venus, of course, is conspicuous. And if we go up into the sky, there's Jupiter pretty much overhead, and it's a nice, bright, distinctive one with all the bright winter stars. And we also have, where did it go? Here's Mars coming up, and Mars next year is actually going to be quite bright. It's minus 1.31. So next January, we'll actually get 4 bright planets in January, so that'll be kind of a neat view. I will say that Mercury is lurking on the other side of the sun. You'd have to, or the other side of the sky. It's an early morning planet, so Mercury's kind of avoiding this one. It's possible that if we go forward or backward in time here, we might find Mercury in the same sky, but I don't think so. So that's kind of something to look forward to in the short term, same as we can see the moon like really high overhead, and instead of cursing it, go, wow, that's pretty fun. So the last thing we're going to do is going to take a trip into the far future. I'm going to go back to today. So does anyone have a guess, and I know there isn't a microphone there, what the sky will look like in the year 13,372? At least according to Stellarium. Yes?
Same as 1942?
No, it won't be same as 1942. Ooh, someone wins a prize, I think. And it's not just that, but there's going to be some other big changes. So people who are familiar with what's going on, and like I say, I'm going to put it to right now, and people are fairly familiar, sorry, I don't mean to, don't tune in too closely or you'll get dizzy. I'm going to throw in the constellations. I think that's the lines. There we go, and this is again is what Andy showed us before. So you'd think you'd see something pretty similar, but nope. I'm going to just scoot this guy out of the way. In fact, we have Scorpius, which we here assume is a summer constellation. and Sagittarius, and they are way up in the sky, way more than we would ever see them here. In fact, this star here, it's called Rigel Centaurus, but it's also Alpha Centauri. And that's the closest neighbor to the sun, and generally right now we do not see it from Canada. You'd have to go, I don't know whether you'd even see it from Florida, maybe. You'd have to go a long way south to see it. And even better, this is the Southern Cross, or the Southern Cross, and it's actually over our horizon in winter in January 13,372. Now you might say, how come Scorpius and Sagittarius are there? This doesn't quite make sense because they're visible. The sun should be there. And that's a question that if people are wondering that, you can ask me during question period. I'm not going to go through all the details here. So what's happening is, just like the moon's orbit kind of wobbles, and the moon's orbit wobbles in pretty short order, like 18 years. So in 18 years, it's going to be high again if you want to wait until 2042. The Earth itself, it's tilted, we know that, that's what causes the seasons. The Earth itself wobbles like one of those tops that you put on the table and spin it up, and it does this. So it's a bit of a drunk wobble, and it takes about 26,000 years, so 13,372 is like halfway through the cycle. And what I will demonstrate, and someone in fact did say it correctly, we're going to pull up the grid of the sky. So we're looking south right now, and we'll pop around to the north. And here we go. Instead of Polaris being the pole star, it's going to be pretty much Vega. Vega is going to be less than a fist's width from the North Pole. It's going to be a bit further away than Polaris is right now, but Polaris is, in that year, Polaris will be quite a distance away. Where is it? Somewhere here. Oh, it's actually down here. Or is it? Yep. Yeah, there you go. So the other interesting thing is that we've gained something. We've gained the Southern Cross. We've gained that whole center of the galaxy, and Centaurus is all now nicely up in our sky instead of just scooting over the southern horizon. However, and here's kind of the problem or the disadvantage, if I go forward to June, so summer, so now it's light at whatever we're at, 8 p.m., because this is June. You know, the summer days are longer, but let's just get into night. So Vega is still up there, but if we go to the south, look at that. Remember this fellow? That's Orion. So we're going to run time a little bit backwards. Whoops. Oh, that's not what I meant to do. So basically, you might be able to catch Orion's belt briefly at the very horizon. You're not going to see Rigel, and as far as seeing the bright stars like Sirius, yeah, forget it. So what happens is we've gained a part of the sky because the Earth has wobbled that way, but we've lost another part of the sky. And the overall scheme, and the easy way to think of it if you kind of know your way around the sky, is anything that's in the winter sky right now is as high up for us as it can be, because the Earth is tilted that way. And anything in the summer sky is as low as it can be. And then, so that means that Orion is a lot higher than it will be then, but everything that's in the low summer sky, like Sagittarius, moves way up as we wobble around and face different directions. So this is something probably you can't see directly, but this is kind of the fun of playing with Stellarium, especially if you have a cloudy night. You can play around with it and see what's going on, because some of these things are pretty neat and it's not really very intuitive. Just to finish up, because I don't have that much more, I just encourage people to go out and try it. You can see there's a whole different set of stars that are circumpolar. So circumpolar stars are ones that never set from a particular place, and in Toronto it's like 45 degrees on either side of the North Pole, never really sets. It might get really low on the horizon and it comes up because it's just circling Polaris, which is a ways up in the sky. Now things have become circumpolar, like while Cepheus is still there, but stars like Altair are now circumpolar, which would never be the case now. Now it's kind of a summer star. So things really change around quite a lot when the Earth wobbles, and the effects are not necessarily what you would expect from just saying that Vega is the pole star. There's a lot of knock-on effects because the sky is still similar, but it's been tilted in a way that you'd go, what's going on? So kind of neat. And that is pretty much my presentation for today. Like I say, it's some bits and pieces that I've shown before, but I am open for questions. Which I hope I can answer.
Thank you very much. Very intriguing. So the whole notion of summer-winter constellation gets turned upside down, and we lose the Orion Nebula. Okay, we have a question over here.
As far as I can see, the constellations are still the same. They're just in a different part of the sky. So how long will we need to wait for them to sort of start dissolving and rearranging?
Okay, so actually, and this is the one thing that I don't think Stellarium really does, is the stars are in fact changing their position in the sky. So 50,000 years ago, I think, or so, the Big Dipper, which is a very familiar sight to us, was shaped quite a bit differently. Yeah, so Stellarium doesn't actually show that. There's probably going to be more distortions in the various constellations than this really shows it, because, I mean, this is a free program and we're running it for, I can't imagine how much calculation it would need to say, okay, we're getting close to this star. For instance, one interesting thing that I've read, and I believe this is true, is we are also approaching the star Vega, so it's probably going to be quite a bit brighter than what it by then than it is now, because this program says, I believe it is actually saying it's the same brightness as it is today, and I think it will be brighter because we're moving in that direction. We're getting closer to Vega. So from the point of view of the precession of the equinoxes, the program is correct. But from the point of view of how individual stars might change and shapes of constellations might change, especially ones with stars that are close to us so they can move apparently faster, it doesn't really show this. You could run it forward 50,000 years, and I don't know what it would show. Probably just take us around in a cycle. But I haven't tried it, so that's something that you can try.
And speaking of far future, do you think by year 13,000 we would encounter the first alien civilization?
13,000 years is a long time from now. 13,000 years ago, I'm not sure anyone was living in North America because I think most of it was covered in glaciers. So that's an open question. I don't know what the answer is. Right now, we're finding that the universe is awfully quiet, though, quieter than we are. Why is that? Who knows?
Yeah, okay, well, you talked about 13,000. Now, I was just wondering about what it would be like, say, about halfway in between, say about 6,580. What would it look like?
Your request is my command. See, this is the fun of Stellarium, right? You just punch it in and you can see, what year would you like, 6,500?
Yeah, somewhere around halfway in between.
Sure.
Yeah.
There we go. So neither Vega nor Polaris is going to be close to the pole, that's for sure, because the whole circle is halfway. In fact, like it looks like the pole star is in the middle of the constellation Cepheus, the king.
Kind of like what the South Pole looks like now, in a bit of a sense.
I'd have to change the location.
Central star.
Yeah, so what we also get is, you can see, actually, so just to see what we see to the south, I'm going to put it to about midnight, so it's going to be, so some things won't change very much because they'll be kind of averaged out. But if we go and we just go through the months, and I'm going to just zoom out, so it looks like Virgo is going to be a bit lower in the sky. That's the constellation Virgo there. But let's just step through. Well, I'm going to run back to January. So Orion's been hit a bit, but not that much. Sirius is still up, so I predict that something on the other side of the sky will be a bit more different. We'll always see stuff that we don't really see very much, but let's see. I mean, you ask a very good question, and this is the sort of thing that you have to play with to see, because there's like a million different possibilities, and it is not intuitively obvious if you know your way around the sky right now what it will look like later. So Scorpius is already getting higher in the sky, because usually in Toronto, that stinger part just barely scrapes our horizon. You can see the stars if you're looking over Lake Ontario and it's clear. But you're getting constellations like this is the constellation Grus. And although Andy mentioned a comet in Grus, it would be in the northern part. But these two bright stars in Grus we really don't see from Toronto. They are just below our horizon. It's already coming up. This nifty thing is the constellation Phoenix. It doesn't look like that. I've been to the southern hemisphere, and no, I couldn't see the jet fighter. So yeah, you're getting already stuff coming and going, but like it's most dramatic when you do the opposite, right?
Yeah,
And-
it seems like Orion is kind of somewhat circumpolar at this time.
Right. So I mean, from now on, Orion will actually be getting lower in our sky, pretty much from now on. But I mean, you'd have to look every 1,000 years to really notice it. But it will be dropping down until it's just like halfway up. Half of it's up, and that's it.
Thank you.
Thanks, that was really interesting. But it did make me think, like the JWST, not affected by precession. But then I thought, wait a minute, the Lagrange points are going to change because of solar precession of the ecliptic. I mean, is that something that you thought about, or how that would affect the?
You know, I haven't thought about that, but actually just the moon's orbit changing around the Earth would change where the JWST is, because you're right, it's in a Lagrange point. I'm not quite sure, I'm not enough of a spacecraft expert to know how that works, but I would trust that they've taken that into account. But you're right, it would mean that the JWST is at a different location relative to the Earth at a certain time over in fact, the moon's orbit cycle of 18 years. It's going to wobble. Yeah, but 26,000 years. So like in each year, you're going to see 1/26,000th. That's probably not that much to worry about compared to the moon going up and down 5 degrees over 18 years. Yeah. You're welcome.
Do you have any questions online? Yes.
We have a question from Frank Dempsey. Will the moon still be visible in 11,000 years, or will there be too many satellites overhead?
That's a philosophical and technological question, which I feel unable to answer at this point. I would hope that we don't have a Death Star orbiting, because that's the only thing that would be bigger than the moon, I think. But the moon's still pretty bright.
Okay, great, and that's all the questions we have.
Good. Any questions in the room? Nope. Okay, great.
Thank you.
Thanks again.